All right, so if you do have a question, put your your video on so I can see you, and then ask your questions. I have here opened up a place to type. I don't know what what you need help with. I made a lot of videos for you. I can show you one thing. Just I saw one question somebody had. It was what's going to be the material? What's going to be given on the exam? You're going to get on the syllabus of the course here. This is the website, the wiki, the Moodle of the course. If you go down here, I know it's in Hebrew, but if you go down here to where it says, where is it? Yeah, where it says MIPS Assembler, that's English. Where it says MIPS Assembler, the first link there, it says in Hebrew, Taksir Pekudot. And if you open that up, you'll see this, which is what you'll get on the exam, which is, you know, add, and, you know, each command here, its format, its opcode. You should familiarize yourselves with how to understand reading this thing. But it's not so complicated. Add the 3 registers, the RS, RD, and the RT. The format, the R, the I, or the J. The opcode in hex. Remember, there's 2 parts of the opcode, the first part and the last part, if there is a last part. Notice for add I, there's no last part. It's just the first part.
Do we need to know that for this course?
Well, I'm telling you, this is what you're getting you're getting this on the exam.
But I'm saying, like so far in this course, we haven't really talked about opcodes or anything. So I'm just asking for the exam for the lab. Are we going to have to be familiar with opcode?
Yeah, both courses sort of want you to know theoretically how to translate, you know, a command. I think it's more in the lecture that you're going to have to know how to translate, you know, this command into its binary equivalent. But you're going to have to know it anyway. I suggest you know it for the exam in this class also. In general, I don't think he asked. I don't recall if there are going to be questions like that. I don't think so, but there might be. And anyway, you have to know it. So learn how to translate this into its binary equivalent. You have to know it for the other class, so you got to know it. As far as this is just to help you, you know, what the commands are, what they do. It says here what it does. For example, add takes the RD, it takes the RS, the RT, adds them together, puts in the RD. And it says in English, add contents of 2 registers. So this you will get. So you don't have to remember what every command does because you have a summary of it, of every command. Load half. Load half word from memory as a signed value. And now the Israelis are getting the same thing, and in Hebrew and in English. So in other words, this is the same one that the Israelis get exactly. No, I don't think there should be any reason why an English speaker should have any trouble with it. I mean, you can just ignore what's written in Hebrew. But you don't have to know this, but you have to know how to use this table. In case you're given, I could ask you, you know, I give you a command with SOAR, and you have to tell me what it does. So this table will actually help you answer that question.
SOAR is not a pseudo command?
Nothing on this chart is a pseudo command.
Do we have to be familiar with the pseudo commands for this test?
No, you do not have to be familiar with pseudo commands. Pseudo commands are verboten.
There's a couple questions in the chat.
Okay, so why don't you read them to me? Oh, you want me to read them? It's easier if you read them to me.
Okay, someone asked what the style of the exam will be.
English. What style? I don't know what that means. It'll be probably, I think it's multiple choice.
Format. How's the exam format for lab?
What?
No.
Multiple choice.
I was asking like the multiple choice, and then basically are we given because in our labs all we've been doing is having to write the code for MIPS. So how would that relate to multiple choice question?
You'll be given a piece of code and you'll say, what's the output?
Okay, so it's mostly output based things.
Yeah, or what will be the value in the register, in this register after this code executes? What will be the value in each register, you know? What will be the value in memory? What will be the value in this memory location after this, you know?
So basically the whole test is just going to be interpreting code.
Pretty much. What if there's an example? I don't think he put an example. Did he put an example?
Yeah, that was actually the other question in the group. Someone asked if we can get practice exams.
Yeah. I mean, I can't do that right now, but I can try that. You can just send me an email. You have my, if you don't have my email, I can tell you it now. If that's a request, I can look for one and I can try to send you. It might be, though, in Hebrew for me to, you know, I don't really, it's a pain to translate a whole exam just to show you. But you can get the idea of the kind of code that you'll see. The code will be in English. And you'll see whether if it's multiple choice or not. It's multiple choice. So send me an email about that to Targilim Danzig that you want a copy of a previous exam.
Is there any character between Targilim and Danzig?
No, Targilim, TARGILIMDANZIG at gmail.com. In general, you can send me questions. Some students have been sending me their code and asking, you know, just cutting and pasting some piece of code from their Mabada and sending it to me in their email and asking me, is this right? You know, is this I'm having trouble with this code. You know, I've had students that ask me, some particular woman from Tal asked me, you know, maybe 20 emails. You know, what does this do? What is this? How come this is not working? And I answer them. So you can write me emails. The world is open to you. I mean, if you ask me a general thing, I'm having trouble, I don't know how to do this. I don't know how to do anything. That's hard for me to answer in an email. That's what we're doing now. If there's something
How
that you
many
have trouble
questions
with.
are going to be in the final?
What?
How many questions will be on the final?
Again, that's, you know, it's up to us to decide. Doesn't matter. I don't see why that's a relevant question. Maybe 20, something like that. But it'll be enough questions that you can answer in the time given.
How long will the final be? The time.
It's probably going to be about 2 hours. About 2 hours. I'm not sure exactly, but I think 2 hours. I mean, I'm saying all of this because the way it works in the school, since we have several schools, the state of Israel wants us to have uniformity in the classes. So I'm not, you know, I can't write the exam. The exam is written by a team of people. I write some of the questions. We all work together, make an exam, and then that becomes the exam. And then we got to translate it into English, and then that becomes your exam. And it's the same exam across all the schools and across all the languages. So real, you know, I don't know exactly how many hours it is. I think it's usually 2 hours. Might be 2.5 hours. Again, it'll be the right amount of questions. It'll be enough. It'll be ample time for you to answer the questions.
I was wondering the amount of questions because I wanted to know if it was the type that we would have to do all of them or like do a certain like.
You know, the exams are always, I mean, exams in this class are always all of them. Well, if there's 20 questions, you have to do 20 questions.
What percentage is the exam?
30%.
30% of our final grade?
Yeah.
And then the rest are the like assignments that we hand in to you.
Yes.
If our assignments work, like the output's good, so does that just mean it's 100?
Basically, yeah. Yeah, basically. I'm not going to take off for inefficiency, but if it doesn't handle certain cases, I will take off. If, for example, you in the powers, you know, in problem 4, in lab 4, you have to do a function, and you have to write a function that does add, you have to write a function that does multiply, and a function that does power. The multiply function has to handle negative numbers, has to handle -7 times 5, and also the reverse, 5 times -7.
If in the instructions it doesn't specify that it needs to handle things, it still does, or like everything we have to handle will be specified in the instructions?
No, everything will not be specified. No, definitely not. But if it says multiplication, it should do multiplication. Shouldn't do multiplication some of the time. Right? If I expect you to know what multiplication is. I expect you to know that if I give you -7 times 5, the answer isn't 35. The answer is -35. That's just the definition of multiplication. Also powers. If I bring something to the power of 0, you should know that the power, anything to the power of 0 is 1. I don't have to tell you the math, I hope.
In assignment 2, like we had to deal with overflow, and I know it would be like a crazy large number, but like, were we expected to deal with overflow if like we just got a number that was too big?
No. The numbers that were entered by the user have to fit into a register. That's not your problem.
Okay, and like,
But
what if
if
there's
the
an
register, if he gave you the number that's the maximum value you can put in a register, and then he gave you another number like 7, then obviously the result is going to be more than what can fit in a number in a register.
and we have to deal
You
with
should
that case?
That case you should handle. That case obviously you should handle. But if a number given is larger, there's no way for you to detect that, actually. That you don't have to handle. That's always a problem. That's always a problem in any programming language. Therefore, in other words, in C++, if he gives you an integer that's larger than 2.5 billion, then you won't know that. The program will just change the number to something else, or you know what I mean? It won't necessarily detect that. The right way to handle this, which you're maybe learning now, is with try and catch. Did you learn that?
We learned it in C++, yeah.
Yeah, try and catch. So I'm just saying in C++, you try and catch, but you also really, the correct way to do it is to take in whatever input as a string. Since the string can be anything. String can be 1,000 letters, 1,000 numbers long, 1,000 digits long. And then parse the string, and then, have a program, a function that goes through the string and sees if it's actually going to fit into an integer or not. That's it. That is the only correct way to do it in any programming language. In MIPS, we're not going to ask you to do that. We're just assuming that he's going to give you a number that is not too large.
But we do have to, you said we do have to check for overflow with addition and subtraction.
No, addition and subtraction, no.
Well, because you said if already we have the number stored, that's like the largest possible integer that we could store with 32 bits, and then we want to add something to it, that's going to be an overflow.
Yeah, I'm not asking you to do for addition.
And
okay,
so
you're
only
talking
for
about
multiplication.
Only multiplication. You're talking about lab 2.2.
That's what I'm talking about.
Yeah, in lab 2.2, yeah, only multiplication. We didn't talk about addition of overflow. Addition of overflow is different, and I didn't teach you how to do that.
So that's an example where like I wouldn't really be certain what situations I'm supposed to take care of.
Okay, so that's why you can ask me. And that's why I give you my email, and you can ask me those questions.
Okay.
If something unclear, you have my email, and you can always ask me.
What is your email again?
Targilim, Targilim, PAR. Here, I can write it here. Targilim Danzig. Targilim Danzig.
I know at the beginning of the year when we had the lesson actually in person, you mentioned that if we hand in exercises like with a lot of time before the due date, that you would consider letting us fix it. Is that still possible?
Well, it's possible. You can send me, like I said before, you can send me a section of your code and say, is this in the right direction for a general answer? And you can also send me, did I handle all the cases in this code? Did I handle? You can send me, cut and paste a piece of your code. Don't send. It's easier if you in the email. It's better not to send me an ASM file. better to send it to me as text.
But could
Then
I
I can
copy and
see-
paste my whole code and then ask you if I handled all the cases?
Yeah, it's a bit of a pain. Then I'm going to check it twice. In other words, then you're asking me to check it and tell you, yes, you got 100, and then you submit it, and then I got to go remember that and check it again and say, yes, I got 100. It's kind of annoying. That's why I say, no, I mean, what I was saying before was when I was doing it in the lab. In the lab, you can show me something and I can look it over if I have time. I don't always have time in the lab. In other words, the lab usually is, you guys do 40% of the work in the lab, 60% of the work at home. And then in the lab, you come in and you say, I'm finished with Targil number, with homework number 3. And I say, okay, I'll come to you, but first I got to check Sarah and then Rachel and then Bracha, and then I'll come to you. And then I go, and you're sitting there already working on Targil number 4 because you're waiting for me. And then eventually I come to you and I look at Targil 3 and I say, you didn't handle this case, fix that. And then you stop Targil 4 and go back to 3 and fix up something. And then I come back again and check. And I say, okay, fine. And then I give you your grade right there and then. That's the way the lab usually works. In other words, even I write on the board, who am I going to? What's the order? You people write your names on the board and I come to you because the lab is not a lecture. The lab is a lab, which means you work, you finish up whatever you didn't finish at home, you finish up in the lab and I check it in the lab. This year, we're not doing it that way because we were not having classes in the labs. And therefore I'm checking on and normally I would ask you, defend your code. I would give you an oral exam on every single homework that you did. That's the way we normally do it. I would say, why did you write this over here? What is this piece of code? Because I want to see if you worked in a pair, I want to see if one person did all the work and the other person did nothing and doesn't understand what he's handing in. So I will make you orally defend your code for every single homework assignment. That's what I would normally do in the lab. This year, you're getting off easy. I'm not going to do that. I'm just going to look at your homework and give you a grade. But I also am not there to check it, to look at a piece of code quickly. But you can send me an email. I mean, I just want you to understand what the normal year would be and what this year is like, because maybe you feel like you would have been Gan Eden, if it hadn't been for Corona. But actually, you're getting a lot of hakalot. All those videos that I made, I never would do. I never would tell you how to do half the program. I did that only this year because I feel like I can't. Normally, I don't go to the whiteboard and start writing code for how to do the problem. I just explain the problem and I say, go to it. Or I don't, I just say, read the problem. If you have a question, ask me, and otherwise go to it. And then I'm just there to answer questions. I don't tell you what to do. I give you pointers. I can give you, ask me, how do you turn a number from a positive to negative? I can try, I can tell you an idea for that. I can say, well, what do you think? But this year, I made all those videos where I basically do half the programs for you, or a third of the programs. Anyway, any more questions?
I have.
Yeah, go ahead.
So I'll continue asking. So it's actually it's still about assignment 2.2. So there were like a couple things that I just did because you said to do, but I didn't really understand. And one of them is like when we wanted to check if it was what was it? We wanted to check if they were all ones in the high. And you said that that's equal to -1 because in 2's complement all ones is equal to -1, right? And
Yeah.
I guess I like missed the point where we said that everything's in 2's complement. I realized that it would be signed, but I didn't realize that it would be in 2's complement. And I just wanted to know, is everything signed in 2's complement in MIPS?
Yes. That's why you learn 2's complement.
Is that
Because
also outside of MIPS?
That's computers how they work. Yes. That's how computers work. Yes, in 2's complement. 2's complement is how computers work, except for floats, which Avi taught you.
Yeah.
Taught you that the floats are not in 2's complement. But
Okay.
yes, all integers are in 2's complement.
And then also when we were checking for the overflow, so I thought that like what we learned last semester in like the digital systems course, was that if it is signed, then we don't look for a carry to detect overflow, that we just look for the sign bit. But it didn't really seem
Say
to
that
match
again.
what
Say
we
that
were
again.
doing.
Say that again. I didn't follow.
Okay, so
It could
when
be-
you're in choose
First of all, it's
component,
been a while. I have never taught digital systems, and it's been a while since I did it. I remember it, but I don't remember all of it. So ask your question slowly.
okay, so when numbers are signed, how we would check for an overflow in digital systems was we would see if the two numbers were adding, if they're the same sign. If they are, then the most significant bit on the solution has to be the same bit. And if they're not the same bits, the two numbers that you're adding, then it could be anything and it's not an overflow. So it just didn't seem to match up with how we were checking an overflow here.
Because that was adding and this is multiplication.
Oh, okay. So it's different rules with multiplication and adding.
Well, I mean, it's what, no, yeah. I mean, I'll tell you like this. I think actually, I have a whole section where I explain this in my slides for the course, but I'm not teaching you the course. But my slides are posted. But anyway, the thing is like this. If you add, I believe, tell me if this is correct. If you add two, let's say 31-digit numbers, no matter if they're both the maximum, the result will still only be a 32-bit number. That makes sense? Not really. If you add them, because if I add, let's say I have 2 bits. I add 3 and 3, and my whole what am I going to get? 3 and 3 is 6. How many digits is 6?
3.
3. So we had 1 overflow. You know what I mean?
But we weren't told to check. Well, when adding,
If
we
I
weren't
have,
told to
if
check
I
the
add,
overflow.
wait, I'm not done yet. If I add, let's say 3, 3, 1, 1, 1. That's 1, 1, 1 is 7, and I add 7 and 7 is 14. How do I write 14 in binary? I write 8 and 4 and 2, right? 8 and 4 and 2 and a 0. So it'll be 4 digits. Notice this trend. If I have 3 digits and I add them together, even at the maximum value of 3 digits, I'll get a 4-digit response. I'll never get a 5-digit response. The maximum is 111. It'll always be exactly 1 digit, never more. If it could be more, then what you said wouldn't have made sense, because if it could have been more, if I could have a 3-digit number and get like 1 and then like a lot of stuff after it, then theoretically the sign bit could still be a 0. In other words, the sign bit, because again, a 3-digit number is what? Again, is 111, for example. And it's going to be 14, which means the sign bit, which had previously been the 4th bit, the 0 there, it really was 0, 1. Correct way to write 7 is 0, 1, 1. Because I'm losing you. I write 0, 1, 1, and I add it to, 0, 1, 1, 1, and 0, 1, 1, 1. That's 7 and 7, I get 14. 1, 1, 1, 0. That's the result. Now, notice that the sign bit, which is the 0, got destroyed. That's always what's going to happen in addition. Nothing else. In other words, you'll never get 2 numbers that are in 4 digits, and the result will be, let's say, like this. Let's say theoretically, I added 2 numbers, and I got a result that was not 4 digits, but 5 digits. And it happened to be that it was a 0 over here. And then when I go and look at that digit, I look, oh, it's a 0. So it's still a positive number, so I didn't have an overflow. I might think that that'll never happen. That'll never happen. And therefore, what you said is true. Therefore, if I just look at the sign bit and I see that it's turned into a 1 or a 0 if it was negative, then I know there was an overflow. And there only was an overflow of 1 digit. What we were talking about is multiply, where I multiply, for example, 1, 1, which is 3, times 1, 1, which is 3, and I get 9. What's 9? 9 is 8, 4, 2, 1. notice that I do not have 3 digits. I multiplied 2 2-digit numbers, and I got, well, I got twice as many digits. Actually, this is a little bit, yeah, I got twice as many digits. So it's actually 2 registers. I have a register, right-hand register and left-hand register. In other words, I doubled the size. So overflow works differently in multiplication because your overflow will be much larger. Whereas I don't need to check the high. The overflow will never go into the high in add. And in fact, add never touches the high. There's no high and low in add. High and low are only for multiplication. So that whole discussion about high and low only is applicable to multiplication. When I add, you're right, it's the sign bit.
Okay, that cleared things up. Thank you.
Sure.
I have one more question about the lab. In 2.1, you said to make a flow chart, and I wasn't sure what you were talking about. So I handed in
you don't
a
have
flow
to
chart.
you don't have to do a flow chart. But you should know what a flow chart is. It is kind of embarrassing if you got a degree in computer science without knowing what a flow chart is.
I've never used a flow chart when making an algorithm.
Well, it's a pity. You should have a you started with Introduction to Computer Science, right? That was
Well, the
first
thing
course.
is, we didn't really start with like a lot of times the Israelis have like a actual
Exactly.
like introduction in the summer, and we didn't have that.
And you didn't have that. So that's it's here. So here's a flow chart. Let's see if I can view that. Yeah. Just so you should know, you shouldn't have what's called in Hebrew chor v'haskala. You shouldn't have a flaw, a missing part of your knowledge. But here we have this is a flow chart, nothing to do with computers, but shows the idea. Incoming, I don't even know. I'm just looking at this randomly. I never saw it before, but I'm gonna just look at it. Every square box is a process, and every diamond shape is a question. So incoming call comes in. The staff answer, this is a process. Call comes in, that's a process. The staff answers the process. This would be like see in, see out, or say out, see in. This is a process. Any function call is a process. A function does something. So it's a process. Then I get the result. Specific staff requested? Question mark. If yes, then if no, then if no, then go to this arrow. Appointment related. Is this related to an appointment that the person has with the doctor? I don't know. If yes, then are you a new patient? If yes, go to new patient schedule. Go to a process called new. Actually, I think these double lines might mean it's a whole nother page, a whole nother flow chart. If no, then go to existing paging schedule. But what about if he was not a specific staff request? If it was specific staff, then the staff from the front desk. And is the staff from the front desk? If yes, then transfer to that staff person.
Well, I understand the idea.
Yeah, and if no, then go to here. That's a flow chart. And it's very useful for loops and things like that. You want to say, is I equal to, is my counter equal to is I equal to the counter? Is I, if not, then do the process and go back to the beginning. And then again, check and do I plus plus. And then is I equal to the counter? Yes. If no, then continue the process. If yes, then print out the result. So you see how this is very useful for diagramming an algorithm. And in fact, ideally as a programmer, nobody does this anymore, but ideally as a programmer, you first do this. You do sort of an independent description of what you're doing because you can change it. You can all of a sudden understand, wait a second, what do I do if it's not like that? I didn't think about that case, and then I add that case. Okay, more questions. So that's a flow chart, but the answer is no, you don't have to actually do it.
You can't make multiple line comments in MIPS
No.
without using the pound sign, right?
No, just like that.
And in the other class with computer architecture, we talked about a command, SLL.
Shift left logical. Yeah.
At this point, are we supposed to be familiar with that, or have we not gotten up to that yet?
Well, I never teach every single command. Once I teach you the basic, in other words, you should go through that booklet that I showed you. It's on Moodle. Sorry, it's on Moodle, yeah. That booklet, that's the first thing I showed you over here. This booklet, it's called Hebrew Taksir Pekudot, and you should figure out all the functions, what all the parameters are. I'm not just gonna, it'd be a very boring class if I went through every single command and what it does. It's not proper to teach that way. You can just read that. If you have a question, you can ask me. If you're asking me specifically on SLL, well, it sounds like you already know because I've explained it, but are you asking me on SLL? Right, I don't hear you.
I understand what the command does. I don't really I just don't see the use for it in like while we're coding. I don't see why I would use it.
Actually, in homework 5 or 6, I don't remember. You probably want to use it.
Okay, so I'll wait till then.
Yeah,
And I'll see.
for an example, I'll just tell you an example. For example, let's say you want to know you've got what register. How many bytes are in a register?
4.
4. Let's say I want to know the most significant byte of my register. How would you find that out? I want to know what's the most significant byte over there. What is it? For some reason, it's, for example, it represents certain meaning. It's a code, special secret code, and I need to know what that byte is, exactly what the ones and zeros are over there. So what I could do is, well, I could do SRL, shift right logical. I could shift all the bits right by 8 times 3. How much is 8 times 3? It's 24. So I would do 24. I would take my register, let's say $4 and $4, and I would write 24. So what this says, it says take $4 register and move it right, move every bit right 24 spaces, and then copy it into the same register, our register 4. So that will erase everything in register 4 except for the most significant byte. And that byte will now be sitting on the right side. So that if I want to know if it's like, let's say the number 7, if that byte represents the binary value of the number 7, then I could now look at it and compare it. I can say, is it equal to 7? That would be a use of, yeah. Go ahead.
But what if out of those 32 bits, the number is only 4 bits, and then like how do you know where the most significant bit is? Because the rest of it's just going to be the sign, right?
No, we're not talking about the number as a number. We're talking about it as a string of ones and zeros. In other words, we're interested in what those ones and zeros are over there. I can view a number. Remember, the computer stores numbers as ones and zeros. I choose to view it as an integer. I can print it as an integer. I could choose to print it as 4 ASCII values. Right? An ASCII value is 1 byte. I could take that same string of 32 ones and zeros and print it as 4 separate letters.
Right, but what I'm saying is, let's say you have the number 4 stored in a register. Okay,
Yeah.
so 4 is 3 bits. It's 1 0 0, and then the rest of the bits are just going to be zeros, right? Because it's a positive 4. Well, if you do this, then you're just going to get that your most significant bit is a 0, whereas isn't it 1?
Yeah. No. That's not what I meant when I said I want your most significant byte. I just want to know what's in byte number 4. I'll give you an example. I did an example of this, I think.
Okay, no, I understand. Sorry, I misunderstood what you were doing. What if you wanted to know what that most significant bit was? What if you wanted to know if that was a 1?
Well, the most significant bit is what mean the most the
Oh, right. I guess it's
32nd bit,
always a 1 because
it's always a
just
1.
ones. Okay, fine.
Unless you mean to say, if I wanted to know what the most significant bit was, where it was, then I would simply, I mean, I could, if I was a C programmer, I would do a loop where I divided it by 2 until I got 0, and then count how many times I divided it by 2, and I'd know where the 1 was, how far over. But that's an idiotic way to do it. That's a C programmer way to do it. We are more powerful. We can shift. We can shift left until we hit a 1. Right? We don't have to do a loop and divide. Division is very
Well, that would
heavy.
be in a loop, no? Like shifting left until you hit a 1.
Yeah, it would still be a
into the
loop, but we wouldn't have to do division. Division is, as you learned with Avi, I think did he give you like comparisons of like different did you do like evaluation of computers to see which computer is faster based on a million of floating point operations a second?
Would that have been in the first chapter?
No, that would have been, it's called like parameters for evaluating computer performance. You didn't do that?
We could have. Maybe I missed it.
Okay. Anyway, division is a costly operation. I don't know if you learned with Avi about the cycles, how many cycles it takes to do a load word, 5 cycles, and how many cycles it takes to do other commands. Division you didn't learn because division is a whole nother ballpark. It's not 5, it's 20. Well, division of floats, at least. Division, depends what division you're doing. You're right, division, divide by 2, by the way, the compiler, if it's smart, he just does a shift right. Let's say somewhere in my program, I have some number equals the number divided by 2. The best thing to do is just shift right. That's division by 2. Right? If I take, for example, take this number, 1100. What's that number? 12. If I shift it right, what do I get? 1100. I shift it right, what do I get? Well, I shifted right, so it goes right. 110. The 0 fell off into the abyss. And now I have 110. What number is that? That's 6. 6 is half of 12. Every time I shift right, I divide it by 2. You say, yeah, but what if it was 7? What if it was 13? Also 6. Well, that's how integer math works anyway. Integer in the world of integers, 13 divided by 2 is 6.
In this course, like with you, we're not going to deal with floating point numbers, right? We're just going to deal with integers.
No floating point. You see over here, it says coprocessor and coprocessor 0. Those
I don't see where you're looking.
Oh, you see my screen though, yeah? You don't see my arrow?
Oh, sorry. Your face was actually blocking your mouse. Sorry. Yeah. I moved it.
Now you see?
Yeah.
It says coprocessor 1. Those are special processors. Notice it says F, these registers. These are a bunch of registers that we never told you about. Secret registers. All these Fs, they're for floating points. There's a whole special processor just designed for floating point math. That complicated. I'm not gonna do it.
You know how like the registers, like the T registers are supposed to be used for different things and like the S registers, but we haven't really been using them that way, right?
No, and I didn't. I have if I let you use the T's the way they're supposed to be used, then I can't get what I want. I can't get you to do the problems the way I want you to do them. So no, the T's, the only difference between the T's and the S's has to do with functions, which I don't know if you got to yet in my explanations.
I haven't.
Yeah, so there is a difference between the T's and the S's. It's only relevant for function calls, and what I want you to do is treat everything as though it's an S. In other words, the T's are temporary. Just treat the T's as though they're S's, which means S is for save, as if they're values that need to be saved. I don't want you to use the T's as T's, but yes, there are some conventions about T's. I talk about it in my slides. My slides, you can see my slides in Moodle actually in the course. But I think I put them here also. Where is it? No, I didn't, but you guys have access to the course anyway. Right here are my guides, and that's the link for today's class. And you have to go to the course if you want to see my slides. I have a whole lot of slides, but the one that's relevant for the lab, I mean, we did a lot of it in class before Corona, but where is it? Yeah, here, this one, sorry. It's this one here. Lecture 1 for both the course and the lab by Nachum Danzig. That one, lecture 1, is definitely worth reading all of it for the lab. You can, this is just my, I did this with you, and I did some of this with you. You should go through it all. Obviously, you know the beginning part, but then I explain your integer multiplication. See, I'm talking about multiplication with overflow. Here I explain about the, oh, I don't explain about the overflows. Here's some floating point operations. I have some discussion of that. You don't have to know that. Here I have a list of some more operations, and here I have a list of pseudo operations, which you're not allowed to use. These are all pseudo. Then I explain here, I explain our SRA and SRL, what the difference is.
Should I still go over the pseudo operations?
What?
Should I still go over the pseudo operations, like if they're not needed?
No, don't. You can ignore them. I just wrote them there so that if anybody used one, I can say, look, I told you not to use it. You used one of these ones on my list. You don't have to know that list. You can just, you don't have to know the, you know, it's like you don't have to know the negative commandments. You just have to know the positive commandments. You just have to know what you have to do. You don't have, if as long as you never do anything but commandments, then you'll be fine. Here I explain LUI.
We can't
Here
use the move command.
What?
So is move a work word we can't use?
Move you cannot use.
Oh, okay.
We don't need move. Move is just assignment. And assignment we do with add. Here's my algorithm for overflow. Here's overflow during addition. You asked about that. We don't have to know that though. Demonstration of an overflow in addition. This is extra stuff I added for when I wanted to teach that, but I don't want to teach that now. Here's how to do functions, implementing functions. This is critical for lab 4. You must follow these rules. And here what I write is, where do I write that? Yeah, here, some conventions. By convention, we do not really need to preserve the temporary registers. This, you won't understand this because you didn't do functions, but then I write, but we do not preserve the T1s in the stack. But in the lab, ignore this convention and store all registers in the stack. In other words, what I'm telling you is, even though the T's you don't have to store, and only the S's you have to store, I want you to store the T's and the S's. So do everything like the S. But save the registers S, but the save registers, which are S0 to S7, do need to be saved in the stack.
When you do like SW, that automatically saves in the stack?
No.
So what does it mean to save in the stack? Sorry.
Well, that's, wait till you get to problem 4, and then you can ask me. But I
Okay.
explain that here. I explain that in these slides. I also explain it in the video that I have for Lab 4. So watch the video, look at these slides, and if you still have a question, then you can ask me. But the video, I should explain exactly what to do. And delayed branching, you don't have to know. Algorithm. What is this? An algorithm for how to multiply using a loop of add and handle negative numbers. This is going to be relevant for I don't know, either 2.2 or 4. Yeah. That's it. The end here is just some like notes. These last couple slides are not really relevant. They're just some notes. In fact, you can stop at some conventions. This you do have to understand. That's relevant for Lab 4. So you see I have 65 slides here. That's pretty much all I ever teach in the lab. All right, any?
Can I ask I want to ask 2 questions. Yeah,
Yeah, just wait.
in terms of debugging your, like, you're going through
Wait a
the
second,
program.
I might have an important call. Just a second. Hello? Hold on. Ken. כן, אבל זה מתקיים? כי קיבלתי אימייל מהמזכירה שזה לא מתקיים. אוקיי. כן. אוקיי. בבקשה, ביי. Sorry. Wait a second. Why don't I see? Oh, here we go. Yeah. Okay. Question. Somebody had a question. Sorry, you're in the middle of, someone was in the middle of the question.
Hila? I think something.
Tamara, I think Tamara was in the middle of a question.
No, I didn't have any questions. I'm good.
Okay. I got the phone call. Somebody was talking. Any more questions? Anything I can help with?
Sometime before the test, do you think we could do like a practice exam together? Because they're in Hebrew, and I'm just not sure if I'll understand.
Yeah, that would be great.
Or if it could just be translated, like not necessarily do together. One
Yeah,
or the other.
we could do one or the other. We could do that. Yeah, sure. Yeah, no problem.
Thank you.
I'll get an exam and I'll do a practice exam.
Sorry,
And send
can
me
I
that
ask you a
in
question?
email also, just to make sure I have that.
So can I ask you, in terms of using MIPS when you're trying to go through a program to see where your mistakes are, 2 things I wanted to know: is there any way to, you know, at the bottom of the screen you have all your your memory and what's stored in every part of the memory?
Yeah.
Is there a way to search for just a specific piece of memory, if you know where it's located? Like,
Yeah, there is, I think.
Because sometimes I found that when I had say a lot of like print instructions, I would have like it would be filled with all my print characters, but I couldn't find the actual array that I was trying to work with in the
What is it?
memory.
Um, yeah. Right, so here you see first of all, let me show you. First, here you see the F here. That's in address 10,010,000.
Right.
Right. And I can do a breakpoint, right? I can run the program by putting a breakpoint here. If I run the program, it runs to that line. And then after that, I can step through the program.
Mhm.
And at a certain point, it's going to put the A, which is that value 10, into location 10,010,004.
Right.
You're asking, what do I want to know what's in a location way down here?
Yeah, it's like for example, you have like the first couple locations are filled already with I don't know printed like input instructions or things like
There
that.
is something
And you
here.
try
Here,
to
look over here. Data,
Yeah.
it's showing me the data of 10,010,000. I can choose other options. I can
Okay.
say, show me the data at location 10,000, 40,000 is the heap, or the current global pointer, or the current stack pointer, or wherever the text is. That would be weird. I could look at the text. I could show me that. And then all of a sudden it's showing me my own text. In other words, it's showing me the encoding. Notice this number, 3C011. It's the same number, 3C. It's showing me the data segment, the data of my code. If I change it to this. And you're asking, what about, you want to know like some random place.
No, yeah. So like I want to know is if when you're defining your data, you defined different say string arrays. Let's say like your result is and then you also defined an array. When
I
I
did
was
something like
trying
this,
to
right?
yeah, then it was like hard to find the array amongst all the rest of things. If that makes sense.
I mean, if I have several arrays,
I had several
One after the other?
messages to print to the screen, and then I had a single array, but I couldn't find the array in the memory. It was there because I used it, but I just didn't know how to find it because.
Well, the rule is that everything is one after the other.
Right.
I don't know exactly what happened in your case, but if I do.
So if you're looking for a specific, I'm just wanting to know if you're looking for a specific, say you're looking for a specific value in an array, is there a way that you can find it in your memory section? Like
Like
if you see
value? Not that I know of, no.
Okay, fine. And then the other thing
But
was
you can view it in different ways. For example, if I do like instead of in a word array, if I do, let's say, ASCII Z. No, I spelled that wrong.
it's 2 hours, yeah.
ASCII Z, and I do like hello. And I compile it. I say, where's my hello? I don't see hello. So then I go like this, and I say, oh, show me an ASCII. And then I see HELLO.
Yeah, so I had something like this, and then I wasn't sure what the array is that I already defined also. Like it
But
would
now the
filter
array I don't see anymore because it's ASCII representation of my array is garbage. Like, there's no ASCII values. There's no ASCII. You can't show it to me.
Okay,
So if I
fine.
want to see the array, I got to go back out of ASCII, and now I see my array values. Here's my F. Here's my 11. Whatever. Here are my numbers that I put in.
Fine.
And
That
here,
makes more sense. Okay.
that's why
So
I have
when
these
I
buttons.
put it on
I can't view
ASCII,
both at the same time.
okay, fine. Thanks, it helps a lot. And also, when you're, in your Mars messages, like if you try to build it and it doesn't work because of a problem, is there any like style or something that tells you what all their like mistakes mean? Like sometimes they're like there's an error here, but you don't know what the error is.
Well, it's
Like
always
that's
a
you.
problem. It's always a problem. It tells you the error. I mean, if I go like this and I compile it,
It just says that there's an error in the instruction.
no, it says SW too few or incorrectly formatted operands. Expected this. It told me. It does say something. Sometimes what it says is very hard to understand. And
Yeah, is there like a place you could look up? Like if you don't understand what it's saying to you, would you just Google it or like?
yeah, you could just cut and paste it and put it to Google and see if you get any results. You could also forward it to me
Yeah.
in an email and say, I got this error message. What does it mean? And maybe show me the line of code.
Okay. Thanks. And then I wanted to know one more thing. When you're working with an array, and you're looping through it, right? And you also have like you're in a loop, so it has a counter. When you were doing your examples, you made your counter, you incremented your counter, and I think you might have used it as a point to the array as well. But when I was doing it, I would only got it to work when I had a separate pointer to the array and then also the counter for the loop.
Yeah, well, I don't think I did that in an example, but normally a counter is just a number like, in other words, a number like 1, 2, 3, 4, it's counting.
Mm-hmm.
As opposed to a pointer, which is, for example, what's a pointer here? A0. If I run this program to the end, and I look at A0 over here, it tells me it's 10,000, 10,000,000, 10,000. Why does it tell me that? Because that's the address where this array is sitting. That's where all the arrays start. That's the first array is always at that location. Now I could theoretically use that pointer as a counter. For example, I could say I want to go through my array. My array has lots of numbers in it, and I know it's got, 5 numbers in it, 6 numbers in it. So what I'm going to do is I'm going to say like this. That's my first pointer. And then, well, these are word arrays. So it's got 5 numbers. I'm going to say like this: add I, and make another pointer. Not really a pointer, another number. It's essentially a number, A0. Not A0, A1. And I'm going to say this number is equal to A0 and another, that's the pointer, which would be also 10,010,000, but plus how many size I've got. I've got 6 elements here, and each one is 4 bytes. 6 times 4 is 24. So I'll write 24 here. Now I could do my loop, and I can increment A0. And when A0 reaches 10,024, I know that the pointer has reached the end. As I know that I've essentially made a pointer at the end, and I have a pointer at the beginning, and I keep incrementing my pointer until the pointers are equal. And if their pointers are equal, I know I've reached the end.
So you incremented your pointer to say by 4.
So then I don't need a counter. Then I have no counter at all. Incrementing my pointers I got to do anyway. I got to increment it by 4 every time to get the next element. Eventually it'll reach the end. And since I've already set up an ending point here, which is a pointer essentially to the end of the array, once I reach that, I can compare pointers. When the 2 pointers are equal, I've reached the end. That I could do. I don't think I did that in any example, but you could do that. Maybe
because the other way would be then to
the other way we have an independent pointer that counts up to 6.
Pointer and then and then
it counts up to 6 and add 1 to it every time, and when I get to 6, I'm done.
And then your pointer to your actual array is incremented by 4 because it's a word.
Right.
Okay. Thank you.
There is one other thing which I never teach, but sometimes we put it on the exam, and that is you can start an array at a certain location. In other words, I can go like this: 0x 10 million. Or was it 10 million? 10 1, 2, 3. No, yeah, that's 10,010,000, right? 10,010,000. And what if I go like this? Look what happened. Look at that F. What is that F? That's the first element in that's my 15. 15 is F in hexadecimal. Why isn't it in the first place at 10,010,000? Because I said, hello, Mr. Compiler or Mr. Assembler. I am now telling you what to put in memory locations starting at this place. I can choose arbitrarily where I want him to put the memory. If I put 8 here, then it'll be 2 spaces off from the beginning. It'll be in that location, right? The F is over here. Now, there's certain things I can't do. If I would write 1 here, it will give me an error. I hope. Let's see. Ooh, it took it? All right, well, that's evil. Shouldn't have accepted that. Oh, maybe I know why, because it did padding. It padded it. I could do that. I started there, but notice where the F is. I started at 1. The F went over a whole 4 bytes, not just 1 byte, because it always starts at word boundaries. That's why these lines are here. It's always showing you, it's always going to write an F at a word boundary, which means every units of 4. So even though I said start at 1, it threw in 3 blank bytes to get me over to the 4 point. That's called padding. Essentially, you can't start a word at this location. It automatically turns it into as though I wrote 4. And just I lost those 3 bytes. 3 bytes is, So
If
that's
you
an
put in a
important
number
thing.
that was less than 1,000,001,000, would it just start at 1,000,001,000?
It's not 1,000,001,000. It's 10,010,000. And that's a good question. Let's try it. 10,000,000. 10,000,008,000. I think it's reserved for the operating system. Yeah, it's not there. I don't see it. So it's over there, 10,008,000. Now I think sometimes it lets me go here. No. See, now I have no way of looking at it. At least no easy way. I think I can make a global pointer. I could make my global pointer because it lets me look at the global pointer, GP. So can I change the GP? Here's the GP. Yeah, here. Look at the GP. It is there. The global pointer is set to where I put the memory, 10,008,000. Now, if I go to the global pointer over here, boom, I see my data. F. And look at the number here, 10,008,000. Now, don't try this because at a certain point, I'm going to go too low and I'm going to hit into the area reserved for the operating system. But just so you understand the syntax that I can write this thing. And that means don't get confused. If, like, I don't know, for some reason, Weinman likes to write, the guy, the Rakaz of the course likes to write at the beginning. His style of programming is to do this at the beginning. He just writes 10,010,000 at the beginning of his program and writes everything. And it may confuse you. You'll see that and say, what does that do? And the answer is, it does nothing. It just says, put it at the place where you would have put it anyway. But you could theoretically put it at a different place. I thought that's what, yeah. Another
I
question?
just clarify one more thing. You know, whenever you're like using system calls and printing to the screen, you often have to save your information first into register A0, right? Printing a string or an integer. Okay. So
Yeah.
so you basically keep like, I suppose, overriding the information that's in A0 to so that you can print
Yes.
whatever it is you want to print.
Yes.
So
And if you
I want to
write
know
it,
when you like, so in your data section, if you define, okay, let's just say you define an array let's say you define an array or a list. The minute you write the word array, it stores it in memory somewhere, so that even if you initially put it in A0, it's still like, you can still get to it.
well, wait a second. This part over here is does nothing. That's just a label for my convenience.
Right.
What really does, the program would look exactly the same, would run exactly the same if I wrote like this, except this line wouldn't work. But here,
Okay.
so that I can use this is pseudo whatever. Essentially, this array does nothing. What does something is that I type .word, and when I type .word, I actually wrote this data to that location in the data memory, and it's there no matter what I do. Now you're asking me if I can change A0 and then again do this command. And the answer is sure. I can do that again. I can do it, I can change A0 and then reset it again. I can do it,
So as long as as long as you put the data in there, it just stays there, and you can access by writing that sentence as many times as you need.
yes.
Okay.
Yes.
So you don't have to worry about like losing information.
This just puts the value 10,010,000 into A0. In other words, it just puts that value, it puts the location of this from data into, of course, I could overwrite the array and then the array would be gone. I could intentionally go and write zeros over there or something.
So you don't really have to worry about overriding or losing anything when you're putting it like extra, like new information into A0. Does it make a difference?
Wait a second.
Because a lot of our programs, you're told to like set the information to initially be in A0, and then you have to use A0 to print things as well because there's only one of them. So it doesn't affect your data at all.
Right. You just have to rewrite the A0 again. Yeah.
Okay, fine. Just checking. Cool.
Any other questions? Somebody, so wait, should we do another Zoom class next week? Or maybe in 2 weeks? Do it next
I
week.
think it'll probably be beneficial when if we're going through a past paper, unless someone has specific questions. So like as soon as, I don't know, that's convenient.
So if I
for
can
you.
get an exam by next week, we could do that.
Yeah.
All right.
Okay. Thank you so much.
Sure. My
Thank you
pleasure.
so much.
Okay. Take care.